Now, let's look at this example. Find the quotient and remainder if the first polynomial is divided by the second. The first polynomial is f of x equals 8 x to the fourth minus 6x squared plus 1. The second polynomial is x minus 1/2. So we want to find out the quotient and remainder if this one, f of x, is divided by p of x, and p of x equals x minus 1/2. Since we have learned remainder theorem, so we may find out the remainder first. What does the remainder theorem say? It says that if f of x divided by x minus c, then the remainder will be f of c. The example is that if f of x divided by x minus 3, then the remainder is f of 3. Here f of x can be anything, any f of x. In our case, f of x equals that. And here was c, here was c, c, and here is 3, here is 3. Now, if here is 1/2, then we should be able to do is find the remainder. Then we need to find out f of 1/2. Okay, so here is f of x. Then this f of x divided by that, the remainder will be f of 1/2. So you need to plug in 1/2 right here. And here are details. You see, f of x is the one right here, f of x, divided by x minus 1/2. Then the remainder is f of 1/2. Okay, so if here is 3, here will be 3. If here is c, here will be c. If here is 1/2, here will be 1/2. Okay, so c is 1/2, c is 1/2. That's our c. Okay, yeah. And here is our c, f over c. So you plug in 1/2 here. If you plug in 1/2, then you will have a 8 times x replaced by 1/2. Okay, and then here this x replaced by 1/2, and then plus 1. That will be 8 times 1/2 to the fourth minus 6 times 1/2 squared plus 1. Now, look, here we then have a 1 to the fourth is 1, 2 to the fourth is 16. Okay, and here 1 squared is 1, 2 squared is 4. So it ends up with 8 times 1/16 minus 6 times 1/4 plus 1. Now here is 8, here is 16, then we have a 1/2. 6 is 2 times 3, 4 is 2 times 2. If we cancel this 2 with this 2, we have a 3 over 2 negative here. So it's 3/2. plus 1 down here. And then you know negative 3 plus 1 is negative 2. Negative 2 divided by 2, that's negative 1 plus 1. So you end up with 0. This tells us f of 1/2 is 0. What is f of 1/2? The remainder. Okay? Yeah, f of 1/2 is the remainder. That's what the remainder theorem says. Remainder of what? Remainder of f of x, this one, divided by x minus c minus 1/2. Again, if here is 1/2, here is 1/2. So this polynomial f of x divided by x minus 1/2, then the remainder is 1/2. Remainder is f of 1/2. F of 1/2 is 0, so it tells us remainder is 0. What's the meaning for remainder is 0? So in this case, we actually find out remainder first. And we know the remainder is 0 already. Okay? For this one. This expression divided by that. So we know the remainder is 0. Remainder is 0 is a very nice thing. Look. 6 divided by 3, remainder is 0. Quotient is 2. So you know 3 times 2 plus 0 is 6. Basically, you know 3 is a factor of 6. Okay, you add 0 means you add nothing. So 3 is a factor of 6. Of course, 2 is also a factor, but here we like to say 3, emphasize 3. Now we know this expression, polynomial, divided by that, you see this one divided by x minus 1/2, we know the quotient is 0. Okay, we don't know, we know the remainder is 0. We don't know what the quotient is. But you know, like the one here, yeah, 6, this one is like over 6. Yeah, divided by 3, you know the remainder is 0, you know you can write in this way. So here you know this one, divided by p of x, you know remainder is 0 already. You didn't calculate the things in between, but you know the remainder is 0. If you know the remainder is 0, you can write this expression equals, is like 3 times 2, you have a x minus 1/2 times q of x. Okay? Yeah, plus 0, fine, but you know you don't need that. So this tells us, you find out remainder is 0, then you can be sure x minus 1/2 times this q of x, you don't know, equals that. This tells us x minus 1/2 is actually a factor of this one. That's very useful for remainder theorem. Okay? How are we going to find out this quotient? You can do this in 2 ways. One is the one right here. You see to the 4th, cube 10 is missing. So you plug 0 here, plug in 0. And cube, and also x10 is missing, so you want 0x here. Okay, you can do the long division. Okay, and then here the divisor, the quotient, you will find out through this way. But you know, we have learned synthetic division. We like to do in this way. Okay. Now you copy 8, 0, negative 6, 0, 1. And again, negative 1/2, you always want to put positive 1/2 here. Let's do the synthetic division. 8, move down. 1/2 times all the time times the last row. So move this one down. 1/2 times 8 is 4, and then always add 0 plus 4 is 4. Always times 1/2 times 4, put the answer here, that's 2. Always plus -6 plus 2 is -4. Always times -1/2 times -4, put the answer here, -2. Always plus 0 plus -2 is -2. Okay, and then -1/2 times 1/2 is -1. You add together positive negative, you have a 0. We know this is remainder, which is 0. Previously we know by remainder theorem we already found f of 1/2 is 0. So this has proved the remainder is 0. Okay. Now this is our quotient. Quotient is the one right here if you do the long division. And then is the one right here. Then you know Q of x is what? Is actually this one. Okay? Yeah. You see, Q of x is actually the one here. Is actually the one here. So you do this by synthetic division. Okay? Okay. So you know Q of x will be that. Then you can put it right here. X minus 1/2 times Q of x. And the left hand side is this one. So let me write it down, would be here. You see, this will be this expression. You put right here, and x minus 1/2 is here. Okay, and the quotient, this is Q of x. You put right here, plus 0. Fine, you don't need that. So you have found Q of x. Okay, Q of x. So Q of x is that. So this remainder theorem is very useful. You plug in, you plug in f of 1/2, you plug in 1/2 here, you get 0. Then you know, you can write f of x, this one, like that. So x minus 1/2 times Q of x. You can either find out Q of x by using this way, or you may find out Q of x later. But anyway, you know x minus 1/2 is one of the factors for f of x in this case. So the factor theorem says what? F of x has a factor, in our case here is 1/2, x minus 1/2, if f of 1/2 is 0. Okay, so here is that we did one case is that like this, is that f of x has a factor x minus 1/2 if f of 1/2 is 0. Okay, we did that. We find f of 1/2 is 0. So then we are sure x minus 1/2 is a factor. So here is what it says. Okay, f of x has a factor x minus 1/2 if this one is 0. Now, what's the meaning for only if? And only if this is 0. This one says that if f of x can be written in this way, then if you plug in 1/2 here, you plug in 1/2 here, 1/2 here, you get 0. So there are two directions. Okay, if f of x can be written in this way, then when you plug in 1/2, you see 1/2 minus 1/2, and here it doesn't matter what this is, because 1/2 minus 1/2 is 0 times this one, you got 0. Okay, So only if means if f of x can be written in this way, then when you plug in 1/2 here, you will have f of 1/2 is 0. Okay, another direction is if you plug in f of 1/2, if you plug in 1/2 into f of x, f of 1/2 is 0, then f of x can be written in this way. So there are two directions here. In general, the factor theorem says that f of x has a factor x minus c if only if f of c is 0. In our case, we did 1/2. Okay, I'll see you next time.